Yeah.
Okay, thank you. So let me see if you can you see the screen?
Yes, Miss.
Okay, thank you. So today, you can all hear me, right?
Yes.
Okay, thank you. Let me start. So today we are moving on to a different topic, which is on pedestrian transport. So pedestrian, these are a group of users which are very vulnerable and they are part of the road system. That is part of the road users. So first, I will go through the lecture slides before we move on to the topic. So we just do a little bit of recap. So at the end of this lesson, every one of you is supposed to know all the pedestrian crossing facilities. There will be 4 classes we'll see later. Then every one of you should know how to design pedestrian walkways. That is paths and ramps. So for pedestrian control, we'll be using the Manual of Uniform Traffic Control Device, the MUTCD, and we will mostly be looking into part 10, that is pedestrian control and protection. So in order to design for pedestrian, we should make sure that we include all the footpath users. So what are these footpath users? These are people with wheelchairs, either a motorized one or a manual one, people with mobility scooters, then children of 12 years old or younger, whether they are walking or on a bike, and their accompanying adults, then people with prams, shopping trolleys, or luggages. And lastly, we'll be looking into people with disabilities. So let's move on to the pedestrian facilities, to the classes of pedestrian facilities. As I said earlier, there are 4 classes. That is either time-separated facilities, physical pedestrian facilities, grade separation, and then warning signs. To start with time-separated facilities, the aim of this kind of pedestrian facilities is to minimize conflict between pedestrian and vehicles. So it does not eliminate the conflict, but it just reduces or minimizes the conflict. How does it minimize the conflict? By allocating short time periods for either pedestrian to cross the roads and for vehicles to start moving. Example of such application can be either seen at signalized or unsignalized intersections. So for example, a pedestrian crossing, zebra crossing, this is normally found at unsignalized intersections. Then we have children crossing, usually at school zones. Then we have pedestrian actuated traffic signals, the one located at mid-block. Then we can have pelican crossings. Then we can have pedestrian at signalized intersection. So the difference between the first one, pedestrian actuated traffic signal, this one is at mid-block, at the road section between 2 intersections, and the pedestrian at signalized intersection, this one is the one that is really at the signalized intersection. So moving on to the physical pedestrian facilities, they also work on the similar principle to minimize conflict, but not to eliminate totally the conflict, just to minimize the conflict and increase safety of pedestrian by using some sort of physical aid within the roadway. Example of such treatment can be pedestrian refuge, traffic islands, medians, curb extension, loading island, safety zones, and pedestrian facing. We can see some photos later. Then we have grade separation. Unlike the previous two, this one works on the principle of eliminating the conflict and also increase the safety of pedestrian because each road user, that is pedestrian and vehicles, will have their own right of way. As the name suggests, grade, so they will all be moving in their own grade, their own levels. Example, subways and bridges. Then lastly, we have the warning signs. These are to warn of the presence of pedestrian or any of the pedestrian facilities ahead. Then let's pass through quickly on the 4 categories of pedestrian facilities, starting with time-separated facilities. We started with zebra crossing. These are just white stripes parallel to the center line of the roadway. They are usually installed where average speed is very low. That is like 50 km per hour or less. It's work on the principle that vehicles have to give way to pedestrian to cross. Then this is the requirement and options for installation. You can pass through on your own, same as this. You can pass through on your own on the installation process. Then we move on to the next one. This one is called a wombat crossing. This is very similar to a zebra crossing, as you can see, but only it's like a raised zebra crossing. It's at a certain height. And it works on the same principle. Vehicles have to give way to pedestrian for them to cross. Then we have children crossing, usually installed on school zones where it's usually on local street where speed is limited. It can either be limited to 30 km per hour. Yeah, you can read this on your own. Then we have pedestrian actuated traffic signals, the one that are installed on the mid-block, an installation of signals at which changes of signal aspect are initiated by a pedestrian. So usually this pedestrian can press a button so that the signals can detect there is a pedestrian, so that a green time is allocated for that pedestrian to cross the road. So mid-block crossing facility for location where significant numbers of pedestrians cross. So it's usually located where there are lots of pedestrians to cross that road. So moving on, still the installation process you can go through on your own. Then for this pedestrian timing settings, we'll look into it later when we go through this tutorial for this question. Then we have pelican crossing. So pelican crossing is similar to the pedestrian actuated traffic signal, the one we just looked at, but this one incorporates flashing yellow display to vehicular traffic, during which a motorist is required to stop only if necessary to give a way to pedestrian on the crossing. For example, this pedestrian is finishing to cross the road, so actually the traffic light here can give flashing yellow, so the driver on the vehicle can judge the situation, and if the road is clear because the pedestrian has already moved, he can start crossing the road. He can start moving even if the light has not turned yet green to him, so he can start moving. So this kind of crossing usually reduces delays. So moving on, this you can read it on your own. Moving on to puffing crossings. This one, they have an infrared detector. This one, they have an infrared detector to detect the number of pedestrians on the road. So it's a little bit more responsive because it can, if it senses that there are a lot of pedestrians, then it can allocate longer time for pedestrian to cross. This green man will allocate longer time for pedestrian to cross. And if it detects less pedestrian, then the green man can just flash for shorter period of time. So it's more responsive than pelican crossing and the other pedestrian actuated signals. You can pass through this on your own. This is just an example of actuated traffic signal at Shibuya Crossing in Tokyo. Then we have pedestrian countdown timers. This one usually display the remaining time for flashing red man clearance interval. Then that was time separated facilities. So we now move on to physical pedestrian facilities. So we start with pedestrian refugee. This one, it allows pedestrians to cross the road in 2 stages. So they can cross the first single carriage for dual carriageway. They can cross the first carriageway, then take shelter where they feel a little bit protected, and they judge the situation, then they can cross the rest of the road later. So it's a place where they can take shelter so that they feel a little bit protected from the traffic. They judge the situation and they continue to cross the rest of the remaining road. Yeah, the same. This is still the pedestrian refugee, where pedestrian cross, then pause a little bit on this refugee, take shelter, then judge the situation and finish crossing the rest of the road. This is, then again, at roundabout, we have Splitter Island. They act as pedestrian refugee, where pedestrian cross, take a little bit pause here, then finish to cross the rest of the road. Same, Splitter Island. Then we have extended curbs. As the name suggests, the part of the curb is extended to the traffic lane so that vehicles can see the pedestrian easily and pedestrian can see the incoming vehicle easily. So it reduces it can also reduce the crossing distance and enable pedestrian to be more visible to motorists. Yeah, this is an example of extended curb. Part of the curb has been extended towards traffic lane. So when the vehicle comes, the driver can easily see pedestrians crossing. So they reduce speed and stop. Then we have pedestrian fencing, which helps to keep pedestrian in their own path. And it's usually near pedestrian crossing to guide pedestrian to the crossing. Then moving on to the next class, which is grade separation. As we talked about earlier, vehicles will have their own right of way and the pedestrian will have their own right of way. So there won't be any interruption because they have separate movements. Example, it's a bridge, an overpass bridge, pedestrian can move on their own and then vehicles can move without any interruption. Or it can either be on a subway. So now, after checking all the pedestrian facilities, let's now move on to providing for people with disability. Is there any question on the pedestrian facilities? Okay, I assume no question. So let's move on to providing for people with disability. While providing for people with disability, a Disability Discrimination Act, it was enacted in 1992, and it was based on designed to cater for people with mobility impairment, those who have difficulty in movement, and for people with vision impairment, those who cannot see properly or cannot see at all. So it aims at providing facilities like audio tactile push buttons, tactile ground surface indicators, color contrasting, cab ramps, ramps to underpass and overpasses, footpath smoothing, and space for maneuvering of wheelchairs. So we'll look into this later. So what is the DDA Act of 1992? This was the general law that removes discrimination among people with disability. So it assumes that all people have the rights to access to premises, goods, and services. So it has three main objectives. Objective number one is to eliminate as far as possible discrimination on the grounds of disability in a range of areas, including all access to premises, buildings, services. Okay, and also the second objective is to ensure as far as possible that people with disabilities have the same rights to equality. And the last one is to promote an acceptance among people with disability so that they have or they feel they have the same fundamental rights as the rest of the community. So moving on, while catering people with disability, we used Australian standard, which 1428. It being a standard, we have to follow it strictly. I believe before this you have learned how to design roundabouts, signalized intersection and signalized intersection. I believe for those one you used guidelines. So for guidelines, you can be a little bit flexible on those, but for standard, you have to follow it strictly. And for part one, we'll be looking into the general requirement for access into new building work. And part two, we'll be looking onto tactile ground surface indicators for orientation of people with which are vision impaired. So moving on to the walkway design, that is the design for circulation space. We will be looking into designing access ways, walkways, ramps, and landing. So you have to, for this kind of walkways, access ways, and ramps, you should provide an you should provide an obstructed width of not less than 1000 millimeter, 1 meter, and an obstructed vertical clearance of not less than 2000 millimeter. By vertical clearance, I mean from the floor surface to the soffit of the ceiling. And the gradient and crossfalls of surface area within a landing or a circulation space should not exceed 1 in 40. So you have to follow this strictly. So as we said earlier, the minimum width, it depends with who you are catering for. If you're just catering for people walking, then you should provide a minimum width of 1000 millimeter. But if you want to include one wheelchair user, then the minimum width should be 1200 millimeter, so that they can have a little bit space for maneuvering. Then if you want to cater for one wheelchair user and another person with a trolley, then your minimum width should be 1500. But if you want to cater for two wheelchair users, then your minimum width should be 1800. So let's move on to walkway design. So for walkway designs, walkway shall be provided with landings, and walkways usually are provided at longer length. They range from 15 meters to 25 meters, and the gradient range from 1 in 20 to 1 in 33. So anything exceeding 25, you have to provide landings. And for the gradient in between 1 to 20 and 1 to 33, you have to do linear interpolation. And make sure that the gradient of walkways between two landings shall be constant. So moving on to ramp design. So the maximum gradient for a ramp should be 1 in 14. And ramps shall be provided. So ramps are usually provided for shorter distances, ranging from 9 meters to 15 meters, and they should have a gradient ranging from 1 in 20 to 1 in 14 to 1 in 20. And anything higher than that, you should provide a landing. And in case of change of direction, the angle of approach should be 0, and landing shall be provided at changes of direction. And make sure when you design a ramp, you should provide handrails. But for walkways, no need of a handrail. Okay, this is an example of a ramp. This is your handrail. Then you have your curb. It is inclined at a gradient of 1 to 14. Then you have a landing with minimum width of 1200. Then you have again an inclined surface. So your ramp, your handrail also should follow the inclination. So if this part of the ramp is inclined, your handrail also should be inclined. Then when you reach to the landing, your handrail should be flat, and then like that. Okay, so as we talked about earlier, the maximum allowable crossfall for ramps and walkways should be 1 in 40. You have to follow this strictly because it comes from a standard. Then we have cab ramps. As the name suggests, these are the ramps at the cab. So for them, the maximum gradient should be 1 in 8. and maximum rise should be 190 millimeter. Then the maximum length should be 1520 millimeter. And then they should align with crosswalk across roadway, and they should have a smooth transition. There shouldn't be no lip. And you should locate a push button within reach. This is an example of a curb ramp. Let's see the elevation or side view. This is the side view. You have a curb here. So for normal users, they can just climb up the curb. But for people with disability or using wheelchair, they have to use some sort of a ramp to climb up the curb. Okay, then moving on to another facility for people with disability. This is audio tactile push button. This is actually for people who can't see because they can't see the traffic lights. So there are some sort of audio that tells them either to walk or don't walk or please wait. Yeah, so that they know when to cross the road. Moving on to another facility, which is tactile ground surface indicators. These ones are installed to alert people who are blind so that they know of a pending obstacle or hazard. They know when to change direction, and they know if there is a continuous accessible path of travel. Okay, let's look at some examples. So there will be directional tile installed so that people who are blind, they can sense it with a stick. If it's a directional tile, this one tells them that they can have a continuous travel path. Then this one is hazardous tile. When they sense this with a stick, they know that there is something dangerous in front of them. That dangerous thing can either be a road or can be a staircase or a ramp. So example, this one is hazardous tile, and in front of it there is a staircase. So when a blind man senses this, he can know that there is danger in front of him. And in this case, it's a staircase. And in this case, after this hazardous tile, then you have a ramp. Or it can either be an escalator or travelators. Yeah, the same thing. You have hazard tiles here, and in front you have staircases. Same here, hazardous tile and staircases. So for example here, a blind man was moving. When they sensed this, these are directional tiles. They knew there is a continuous movement, so they move in a continuous direction. Then when they sense hazard, they know that something is about to happen, and in this case there was a staircase. Yeah, the same thing. There was directional tile, there was continuous movement for them, then suddenly the hazard tile, because there is direction of traffic flow. So in this case, this is a road, traffic flows here, so they will be a bit alert. Same thing. You have directional tile, they know there is continuous motion or continuous path. Then there is hazard tile, they sense danger. In this case, it's a road. Same thing. Okay. Same thing. This one is in case of change of direction. They were moving in this continuous path. Then you have hazardous tile here. And in this case, you have another direction of travel so they can know where to travel. So if you become a transport engineering, you have to incorporate the design for people with disability into your design. Make sure you incorporate. And some people tend to misuse this kind of facilities. You can find some people parking on top of these directional tiles when a blind man cannot know where to pass. Okay, thank you. So now let's move on to tutorial, to the tutorial questions. First, is there any question? Does anyone have any question? Okay. Is there any question? No question? Okay. Let's move on to tutorial 8. Okay. Let's move on to tutorial 8. The first question, it's fill out this table with either appropriate, maybe appropriate, or inappropriate. You have different pedestrian facilities like median refugee, cab extension, fencing, speed control device, pedestrian zebra crossing, children's crossing, pedestrian operated signals, and grade separation. So you have to state where if you want to install them in primary arterial, secondary arterial, collector road, or local street, where will they be appropriate? So for median refugee, this can only be installed in low volume roads like collector roads or local street. It cannot be appropriate for arterial roads because arterial roads are high volume, they have a lot of traffic, they high capacity roads. Same with cab extension, can only be installed or can be only installed in collector road or local road because they have low volume of traffic. Then for fencing, this one can be appropriate for arterial roads because it has a lot of traffic, but it's inappropriate for local road. You don't need such kind of safety for just a local road because it has low traffic volume. Then for speed control devices, for example, you limit the speed maybe just 40 kilometers per hour. So this can only be appropriate for local street, but it's very inappropriate for arterial road because these cars or vehicles moving at such high capacity road, they usually move with a very high speed. So likewise for zebra crossing can only be installed in local street road. For collector road, you should check where you are going to install it, check the number of traffic there, but it's inappropriate to be located in arterial road because cars are moving at a very high speed and there are a lot of cars. Same as for children crossing, you have to install it in local street where you can limit the speed. And for pedestrian operated signal, these are very appropriate to be installed in arterial roads because they work on the principle that a special time, green time, will be allocated for pedestrian to cross the road. But it's very inappropriate to be located in local street. No need of such advanced signals operated for just a low volume road like a local street where there is no much traffic. Then grade separation, this one is inappropriate to be located in low volume roads like collector road and local street, but can be applied in arterial road. Yes, now let's move on to question 2. So question 2 is about pedestrian walk and clearance time. We have to calculate the time it takes for pedestrian to cross the road, both walk time and clearance time. The first question wants, what times would you use at a crosswalk across a 15-meter undivided road 4-lane? So for the first one, you cross a 15-meter undivided road. The second question, what times would you use at a crosswalk across a divided road with one roadway 11-meter wide? So this is a divided road. One roadway is 11-meter wide. The other one is 15-meter wide, and they're all separated with a 3-meter median. So at first, if you assume a full crossing, so it means you cross you cross the 11-meter wide road, then you pass through a median, and then a 15-meter wide road, just at a single spot. You don't stage your crossing. So the first one, you assume full crossing. You cross the whole road at once. Then B, you assume a stage crossing. It means that you cross the 11-meter wide, you stop at the 3-meter median, you take a shelter a little bit, then you start again, you cross the remaining 15-meter wide. So assuming a stage crossing. So let's start with the first one of what times would you use at a crosswalk across a 15-meter undivided road? So for this question, there is a graph in your lecture slides, this one, where you can use it to calculate your pedestrian walk time and clearance time. The y-axis is time in seconds, and your x-axis is your walk distance in meters. So the first graph, is for you to calculate your walk time. And this one is for divided road. You can either use this formula or you can directly read the graph. Then graph number 2, it's for calculating walk time, and it's for undivided road. And graph number 3, this one is to calculate flashing clearance time. So the clearance time, this is for maybe slower pedestrian, because when you allocate, we assume that pedestrians usually move at 1.2 meter per second, but sometimes there are some pedestrians who are very slow, so we have to allocate a little bit of flashing clearance time for them to finish crossing the road. Okay, so to calculate the time pedestrians take to cross the road, then you have to add the walk time and flashing clearance time. So starting with question number 1, we assume that the pedestrian crosses the 15-meter undivided road. So when 15-meter, it's about here. So it's undivided road. So we have first to calculate the walk time. You go to the graph for walk time for 15, then it's 8 seconds. So they will have a minimum walk time of 8 seconds. Then again, we have to plus with the clearance time. So for 15-meter walk distance, flashing clearance time, if you just read from the graph, should be around 10 seconds. But also you can still use this formula. You will divide your walk distance, 15-meter, divide by 1.5. Again, you will get 10 seconds. So when you add these two, you will get the time for pedestrian to cross a 15-meter undivided road. Then moving on to the next question, which wants us to calculate the time to cross a divided road. Let's first assume a full crossing. We cross this road all at once. So if we cross all this road at once, then we'll be crossing 11-meter wide first roadway, then plus the 3-meter median. So it will be 14-meter, then plus 15, the other 15-meter, the remaining of the roadway, which will sum up to 29. So we'll be crossing a full 29-meter wide at just one spot. So we'll first calculate because it's divided, so we'll just calculate first the walk time. So we said it's around 29. So it's around 29 here. You have to read the walk time. Then after reading the walk time, you have to read the flashing clearance time. Again, around 29, you read the flashing clearance time, or you can just use the formulas. Yeah, so if you assume a full crossing, the minimum walk time, as we said, for divided road, this one is for the divided road, we have to take 2 plus walk distance divided by 1.2. So 2, you will be walking through the whole 29-meter wide road, then you divide by 1.2, you'll get like 27 seconds. Then you have clearance time. Okay, for slower drivers, you can use this formula. You walk distance divide by 1.5, or you can just directly read from the graph. If you read from the graph, you still get around the same answers. So we are done with full crossing. If you assume full crossing, this is the answer. Now let's assume staged crossing. By staged crossing, we mean you cross the 11-meter wide road. You treat it as undivided because you crossed it as just one road. Then you take shelter at the 3-meter median. Then you finish the remaining 15-meter wide road. Okay, so you'll treat it as the first 11 meter wide, you'll treat it as undivided because you didn't cross all of it at once. So it's 11 somewhere here, so you'll have 8 seconds. You'll have 8-second walk time for that 11 meter wide. Then you have again your clearance time. You can read your clearance time, or you can just use the formula. You divide the walk distance, in this case it's 11, divide by 1.2. Then you are done. You are done for that first part. Then we move to the next part where you cross the remaining 15 meter wide. So 15 is around here. You read your walk time and again your clearance time. For clearance time, you can still also use the formula. Then you add the two parts together. So for stage crossing, as I said, you'll have 8 seconds for both roadways. That is 11 meter wide and 15 meter wide. So when you cross the 11 meter wide, your walk time, because now you treat it as undivided because you didn't cross it at once, you'll have 8 seconds for walk time. And for 15 meter wide, again, you'll have 8 seconds for walk time. Then finding clearance time for the 11 meter wide road, your clearance time is about 7 seconds, and your clearance time for 15 meter roadway, it will be around 10 seconds. Then you just add all of these times together, you get your total time to cross the road. Now let's move on to question 3. Unless anyone has a question, then you can just unmute and ask for question 2. All right,
Miss,
yes.
so for 2A, the
Yes.
the total time to cross is actually 8 seconds plus 10 seconds, right?
2A.
Yeah, the previous one.
Okay. Here, right? Yes, 8 seconds
Yeah.
plus 10 seconds. 18 seconds.
What is the minimum walk and the clearance meaning again?
Okay. So the walk time, this is usually the time that is allocated for pedestrian to walk. But because we assume that pedestrian walk at 1.2 meters per second, but actually there are some pedestrians who are very slow, so they can take longer than 8 seconds. So we allocate some flashing clearance time whereby the traffic light will be flashing green for them to finish crossing the road if they were slow. You understood? So we allocate
Yes.
some clearance time for slower pedestrian to finish crossing the road. But actually for them to walk was 8 seconds. But if they are a bit slow, we give them a little bit more time for them to finish crossing the road.
Oh, so the clearance time is basically the additional time for them to cross the road. Okay.
Yeah. So at flashing time, so your traffic light will be flashing, the green light will be flashing for them to hurry up.
Okay, understood. Thank you.
Oh, yeah. Okay, let's now move on to question 3. We have to describe the main features of the following pedestrian facilities. Okay, starting with zebra crossing. The main features, these are white stripes parallel to the center line, and they're usually located at speeds traffic speeds, located where traffic speeds are low, example, at 50 kilometers per hour. And then we have wombat crossing. As I said earlier, this is same as zebra crossing, but it's just raised. It's a raised crossing. Then we have pedestrian actuated traffic signals. These ones are initiated by a pedestrian, and usually they have a button to be pressed. Then we have pelican crossing. So the difference between pedestrian actuated and pelican crossing, the pelican crossing, I said earlier, it has a yellow flashing display. It has a yellow flashing display so as to reduce delay, so that the driver, if they judge the situation, there are no traffic, they can start crossing the road earlier. So it reduces delays, not as pedestrian actuated traffic signals. Vehicles can only move when they have green time, even if the road has no any pedestrian, but still they have to wait because their time is red. But for Pelican Crossing, yellow display so that if the driver judges there is no any pedestrian, they can start moving earlier. Then we have puffing crossing. This one has microwave and infrared detector to detect the demand. If there is high demand, then it will allocate longer time for pedestrian to cross. Yeah, so it's more responsive. Then we have extended curbs. As I said earlier, part of the curb has been extended so that vehicles can see the pedestrian easily and pedestrian can see the vehicle easily. Okay, then moving on to the next question, question 4, we have to define the objectives of Disability Discrimination Act of 1992. Actually, you can just pass through the lecture slide. We have talked about the 3 most important objectives. Number 1 is to eliminate as far as possible discrimination against persons of disability. Then, as far as practicable, that persons with disability have the same rights to equality before the law as the rest of the community. And the last objective was we should make sure we promote recognition and acceptance within the community of the principle that people with disability have the same fundamental rights as the rest of the community. Then moving on to the last question, this is a little bit more challenging. You have been requested to quickly propose a DDA compliant path or ramp between an existing car park. You have an existing car park and a building entrance, and you are required to nominate path width, path grades and length, landing requirements if required, where and how long, and information at hand is shown below. So you have a building entrance, which is at reduced level of 11.39. Then this is your proposed path alignment. Then you have a finished level of your car park, which is 10 meters. So it's lower, 10 meters low. And this is your horizontal width between building and car park, 22.5 meters. So you have to design either a path or a ramp. So whether you provide a ramp or a walkway, it will depend on the gradient and the distance you use. So as you remember, for ramps are designed for shorter distance. It was between 9 to 15 meter with gradient ranging from 1 to 14 to 1 to 20. And for path or walkway, it's between 15 meters to 25 meters with gradient of 1 to 20 to all the way to 1 to 33. So depending on which one you use, we will know whether it's a ramp or a walkway, depending on the gradient you will use. So in this case, you are also asked to nominate path width, and that will also depend which category you want to cater for. For example, if you want to cater for single road, single users, single person users, that's minimum width was 1000 millimeters. But if you want to cater for one wheelchair user, then it has to be, you have to provide minimum width of 1200. So it depends with who you want to cater for. So your answers can vary from one person to another, and the answer should come in a drawing form. So make sure your answers come in a drawing form so that you just label everything on that drawing, what has been asked here. So as I said earlier, for accessways, walkways, ramps, and landing, they should have an obstructed width. All this is in your lecture slides. I'm just recapping, I'm just revising with you. You should have an obstructed width of not less than 1000 millimeter. Then your vertical clearance should not be less than 2 meters. So if you're designing a walkway, the distance should be from 15 meters to 25 meter, and this gradient should range from 1 to 20 to 1 to 23, and anything in between you have to do linear interpolation. But I've done linear interpolation for you already here, so when you're doing your question, you can just take the values from here. You don't have to interpolate again. And if you want anything exceeding 25 meter, you have to provide a landing. And anything exceeding 15 meters, if you want to still use this grade, then you have to provide a landing. So for this gradient, this is the maximum distance that you can go. For distance longer than that, you have to provide a landing. Same for ramps. The distance is 9 meters to 15 meters, and the gradient is 1 in 14 to 1 in 20. Anything greater than that, provide a landing. And make sure if you design a ramp, you should provide handrails. Okay. So to start with, so what you can do to start, you all know the difference. Let's see. You know the difference between your building and your car park. So get the difference here so that you know your vertical distance. When you minus 11.39 and 10, you'll get 1.39. That is your vertical distance. Also, you have your horizontal distance already. So calculate first to get the ratio. Then after getting the ratio, start designing from there. So I'll give you like 10 minutes for everyone to design either a walkway or a ramp. You have to judge it by yourself. Or anyone who has a design already, they can share with us on the chat box. Otherwise, I'll just give you 10 minutes for you to design. Then we'll come and discuss. If anyone has the design already, then you can share your design with us. Otherwise, I'll give you 10 minutes for you to try so that you know how to design. Your answers can vary depending on the slope. So first calculate the ratio there. So don't just use all the ratios blindly. Calculate first and know which ratio to use, then we will discuss. Let me just share for you the interpolation so you don't have to interpolate again. Yeah. See you after 10 minutes. Okay, now let's move on. I believe everyone has tried. Okay. Okay, so what you're supposed to provide is something like this. Sorry. Yeah, you're either designing, if you're designing a ramp, you should give a drawing like this in your design. So for example, you had your first trial. We all know our building level is 11.39 and our car park is at 10 meters, 10 meters, right? Then when we minus, we get the vertical distance to be 1.39. Then when you calculate the ratio based on this horizontal distance and vertical distance, the ratio is 1 to 16. And a point of reminder, the gradient has to be in whole numbers. I believe when you calculated, you got around 16 point something. So you have to keep it in whole number. So the ratio is just 1 to 16. But if we checked earlier, 1 to 16, the maximum distance you can go is 11.5. So 22.5 has exceeded the maximum distance. So we cannot, it's not allowed to provide a ramp with this gradient for a very long distance of 22.5. What happens is, like, when a wheelchair user starts using it, he or she will get fatigue because you are inclined at a very long distance. So it's not allowed. So if this is not allowed, then we have to go for a second trial. Second trial is try providing a landing. So if you try providing a landing with a minimum width, this is the minimum width. You can go higher than this, but you're not less than 1.2 meter. So if you provide this as your landing, then you have 22.5. So 22.5 minus 1.2, then divide by 2, you can get this horizontal distance to be like 10.65 and this one 10.65. And again, 1.39, you divide it by 2 to get this. So when you do that, you can get the gradient you want, or otherwise you can just check. So if you want to use, for example, 1 to 15, but 1 to 15, the maximum distance should be 10.3. And when you calculate it there, you get 10.65. And for 1:14, the maximum distance has to be 9. So even if you want to use, for example, 1:14, so then you back calculate the horizontal distance. Make sure when you add this horizontal distance, after choosing any gradient here, use the vertical distance with that gradient to get the horizontal distance, then get this horizontal distance, and make sure all your gradient has to be constant. This gradient and this gradient has to be constant. You should not be providing different gradients. Okay. Then when you add the horizontal distance, all the horizontal distance, make sure they sum up to 22.5. So if you provide one landing and you still try and it does not fulfill this requirement, you do not get the same horizontal distance or the vertical distance, then you have to go to the third trial. The third trial, you provide another landing. So now you'll have two landings. So you provide two landings. So first you divide your vertical distance into 3. You divide your vertical distance into 3 portions. You just take 1.39, divide by 3, you get 0.46, you get into 3 portions. Then you use gradient 1 to 14, the steepest one. You use this gradient with vertical distance, then you get your horizontal distance. You do that for all the 3 parts. Then after that, you take 22.5, you minus 3 multiplied by 6,480. Then you know that all the remaining length, you spread it into, or you distribute it into your landing. So in this case, your landing will get 1530 because that 1.2 was just the minimum. Yeah, this is how you do it. And point to take note, make sure the gradients are constant, are the same in all the inclined part, and they should be in whole numbers. But length can be different if you want. Yeah. Is there any question? I think that is the end of our tutorial. Is there any question? Yes, gradient has to be constant through all the slopes. If you have more than one slope, they should be the same. Because when the wheelchair user, for example, you provide different gradient, so he start walking in this part of the road, the gradient is different. He come into a landing. Another part, the gradient is different. It's hard for them to cooperate. It's hard for them. So it's better you provide the same gradient, so that they don't be moving up and down, a steeper one, then gentle one, steeper, gentle. No. Okay, thank you. Any other question? So the answer can vary. So your answer can vary from one person to another, as long as you provide your horizontal distance sums up to the same number that is given, and vertical distance. Yes, the landing minimum is always 1.2. That is the minimum. You can exceed 1.2, but it shouldn't be less than 1.2. Okay. Any other question? Is there any other question that you'd like to ask? Is there any other question you'd like to ask? Okay. In case of any other question, you can just drop an email. Okay, thank you. You all have a nice day and take care. See you on the next tutorials. Okay, bye and thank you. Thanks. Okay, bye-bye. Take care.